Good afternoon. Well, here we are. We're back doing some more stuff that I've wanted to do for years for the old Logan lathe. And once again, I refer to Adam Booth on how he manipulates that huge lathe he has as far as when he gets down to a really fine cut, he does not rely on the dials on his cross-sliding compound, and he always places a mag back right out here, and then when he does something he can return this to zero. Well, as I showed you before, when I was making these indicator holders that fit up by the headstock of the chuck on the V-way, there's just not room on these small lathes to put this big 2-inch indicator. So anyway, that's what we're working on right now. And I don't like to do like a lot of other eBayers do. I do not like destroying an old piece of equipment like this Logan lathe. In fact, I've never drilled a hole in any of my 3 lathes. So I try to do everything to leave the lathe in pristine vintage condition. So let me stop this for a minute. Okay, so here we're back, and clear out here on the back edge of this to where it really, so far I haven't seen it makes any difference in working with it. I simply made this removable piece, and this, as I always do, I start out with plastic starboard, whatever you want to call it, and this happens to be a piece of 1/2-inch birch plywood with melmeline on it and a couple magnets. Now it would take 2 more magnets, but I have them ordered. I really don't have them right now. So I thought of a lot of different ways trying to figure out how to make this usable. I thought about maybe trying to put something down here where the follow rest goes, but then of course you see what happens. You bring the chuck up, that hits. It's out of the question to put it on the far side over here on the chuck side. Can't put it out front, there's just not enough machine there to do it. So I'm sure I'll get my arm in the way or else knock the camera over. But anyway, these standoffs, you can make whatever length you want. These are 2 inches, so it's about 1 3/4 inches by 2 inches by 1. And it slams on here like so. And the way it's made, I'll move the mag base for a second. As you get way deeper, this is about where my tool bit would interface with the work. Okay, rarely do I do anything to where the tool, the cutting bit, sits way back behind. Alright, so anyway, you take this piece and it snaps in place, and if you're going way back there, you can just keep repositioning your mag base until you get what you want, and you can keep on going to whatever the travel of your base is. Alright, so with this I'm going to bring it back out here to a more realistic area that I would be using it in, and then simply push the base up and get it as close as you want to zero. And I found, even with this plastic and the plywood, it really, you can flex it. Now don't forget there's only 2 of the upper magnets in place and not the 2 lower ones, but you can see I can push this, but it returns almost perfectly to zero even with all that flex. So the idea is you want to get a few extra thousandths, and you have the 0 as your reference. You want to go 5 thousandths, you go to 5 thousandths. Make your cut and try whatever you're going to try, and you go right back to the same thing. So anyway, I will show you how I make this, and if you like one, go ahead and make it, and if not, just forget it and have a great day. Later. Alright, so what I started with was a piece of aluminum bar stock, and you know, the sizes are not too specific. This is a hair over 1 inch, but I'm not going to machine it down because literally it doesn't make any difference. So it's about 1 3/4 by 2 by whatever the width is. I think it's about 1 1/8 inches. So I started by whacking them off in this bandsaw, faced one end, put a stop in place, faced one end to one, put the other one in, faced that end, and then of course from there brought this over to the stop, locked it down, and faced the first one off, removed it, dropped the second one in, and faced it off. So what I ended up was with two pieces exactly the same for length, and easy to do. Alright, the next thing I'm going to do is I took the wooden pattern, the back part, and I transferred that information to a piece of 3/8 inch aluminum plate I happen to have. So I removed these stainless cap screws, simply laid this piece down on top of my aluminum plate and went through the existing holes in here using a transfer punch. So I ended up with my 4 dimples in here to spot my holes for my bolts that are going to hold it to the other aluminum blocks I just showed you. While I was there, I scribed the hole here that the compound extension is going to go through, and did a little radius on the top edges and dressed it up. Not that it has to be done. So I'm going to go ahead. I have to cut this down with a bandsaw to get it in my vise. That vise is about a 4-inch vise plus a couple hundredths. It's not much at all. And I don't like pulling the vise and mounting the stuff to the table. It's just too much trouble. So this thing's going to be 4 inches plus a hair. Now this is my 14-inch wood cutting Delta bandsaw, using just a standard 3/8 wood cutting skip tooth blade. And I would guess that this thing has probably cut more aluminum than it has wood. So anyway, this is going to be pretty noisy. Okay, so we basically have it cut out. See you in a bit at the mill. Okay, I know I'm going to get lambasted for machining this standing up on edge like this, but what I've done is there's a place out there on eBay that sells monster jaws, and they're really quite inexpensive, 20 bucks a set, or 22, something like that, for a 4-inch vise. And I've got a pair of those in here, which raises up about a 1/2 inch on this 3/8 plate. And I'm only taking about 5/1000ths of a cut. All I'm trying to do is square it up. And I'm just not going to pull the vise and set up everything to do it the correct way. So here's cut. And there's no vibration or anything. And really, I mean, this doesn't have to be perfect anyway. It's just how good do you want it to look? And when I get done with this, I'll not video the other part over here, which will really make you cringe because it's going to be 6 inches tall and only 2 inches of it's going to be supported. Then I went ahead and squared up the sides and found the corners here, 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 and here. I don't have a digital readout, so I simply set up both ends of the table to 0, and doesn't work as well as the DRO, but it's fine. Anyway, we're going to drill the holes with a bit because the end mills I have aren't really very good center cutting, and they really struggle. And I'm just taking it easy because this is not ½ inch. It's one size under, running in a ½ inch collet. Because I'm just kind of lazy. I don't want to, well, you see what happens when you get lazy. Alright, well, we got the 4 slightly undersized holes drilled, 1 in each corner. And of course the only one that I had a problem with was the one that was caught on video. But anyway, they're all 4 drilled. Now the next thing I'll do is put a ½ inch, actually it's a regrind ½ inch bit in, and so we'll cut around. It'll take a couple 3 trips on this mill, so we'll be back when we're ready to do that. Thank you. Okay, what we're doing here is just I'll use the term hogging lightly, because I don't have a roughing mill to do this with, so I just take it slow, about 50 thousandths each pass. And with this small mill, it takes a few passes. But nevertheless, this is a last pass on the back, and I'm simply going to do the same thing all the way around. And after I get that done, I'm going to increase my stops about 3 or 4 thousandths and climb mill all the way around it to clean it up. Not that it, not that it makes any difference how it works. It'll just look a little better. So I don't know if you've ever had any trouble with hoses for vacuum cleaners when you're around cutting fluids and all this kind of stuff. But I found out a good thing to use the second-hand hoses from my wife's swimming pool. It uses kind of a creepy crawler thing, and after about 2 years, the creepy crawlers give up, and it's cheaper to buy a whole new kit than it is buy just the head. So every couple years, I get complimented with a whole crap pot full of nice flexible hose that works very nicely. Nothing seems to bother it, and if it goes bad, I know in another 2 years I'm going to have 8 or 10 more of them. So later. Okay, here we are making a final spring pass around this. And I won't show you all of it, of course, but not really necessary, just makes it look a little more presentable. after we get this done, we'll come in here and we've got these marked. We'll spot drill them and go ahead and go through that and the actual mount blocks with the number 7 drill bit, get ready to tap things. And we'll stop here. Back in a little bit. All right, we're back, and to keep from boring you too bad, what I've done so far is taking this aluminum 3/8 plate, and if you remember right, I had punched and marked 4 holes, mounting holes for the aluminum blocks. And there's one mounted. The holes are drilled on this one, except what I'm going to do is drill this number 7 hole through all the way on. I've done that on all 4 of them. This is the last hole. And I do that for 2 reasons. First of all, it marks the spot on the other side to put the magnet. It makes tapping easier because you're not tapping into a blind hole. And thirdly, if you fit the other side too tight and have trouble pushing the magnets in, the hydraulics will take over. This way you can push the magnets in before you mount the plate, and there's an escape route on this side. So that's the theory behind all this anyway. I don't know what this aluminum is, but it's just something I had laying around. And it's a little gummy. And even with WD-40 to lubricate it, it doesn't do wonderfully. I do love this little Albrecht chuck though. Alright, the next thing we're going to do is tap it. And I'm sure you've seen tons of power tapping online, so once again, won't bore you with that. Alright, we've drilled all the through holes from the other side, which I told you we're going to mark where we're going to drill the 1/2-inch holes for the magnets. And I think I already told you before that don't drill them too tight, because the magnets come in and they're of different sizes. The first ones I drilled a hole undersized, reamed it to 1/2. It wouldn't go in. Went with a 1/over reamer. It wouldn't go in. So I found out just use Loctite. And it will make up for the little bit of difference without having to kill yourself, because after you get those magnets in these holes, they're pretty rough to get back out. Okay, I've got the stop set already for 3/4 of an inch. We've got a nice pilot hole. I love the stub bits. Just looking at the dials on the machine. I set it back to 0. That's it. Now just take a file here and do a little draw filing to knock the burr off, which is really not much. Okay, so we're simply going to move it over, do the other side, and then this block is pretty well done because I'm waiting for the magnets to come in. Okay, good morning. Just one or two more short little clips and then we'll put this together for you. And the last thing we did was we drilled the 1/2-inch holes for the magnets in the standoff blocks, the aluminum blocks. And you can buy your magnets from whomever you want, but this CMS magnets, and they're on eBay, and that's where I bought these from. They're one of the few that actually give you the pound pull on these magnets and guarantee you to be happy with them. And let me tell you, they come with lots of warnings, because let me tell you, these things are strong as the devil. So this is what I used. These are 1/2 by 3/8, and they're strong enough that they come with nylon spacers between them. And I'll tell you right now what you need to do before you try to put them in whatever you're putting them into. Mark the tops as they come off this stack, because after you get them off this stack, the only way to know which is north and south pole is put them back on this stack. And when you try to put them into anything, if they're beside anything steel, metallic, or another magnet, it's almost impossible to flip them over and get them correct. So with all that said, this is the finished product now. And I decided to put 4 of these magnets in, 2 in each block. And here are the little plastic standoffs I was telling you about that separate the magnets. One of the difficult things is these magnets, you know, they may say they're 1/2 inch, but it's hard to say exactly, you know, thousandths of an inch here and there and so forth. And when you try to take a micrometer to measure them, well, first of all, it slams into the micrometer, and they're really tough. So my suggestion is to make these mounting holes a little oversized and make it easy on yourself. Use some of this Loctite. It's 20, and it'll fill up to 15 thousandths of an inch gap and still provide you 3,800 psi. It's a retaining compound. The next thing I had trouble with was trying to get them in the hole, because they kept wanting to flip, and if you take a hammer or anything metallic and try to push them in. So I'll try to show you here how I did it. And let me tell you, these are tough to get apart. But anyway, start and you slide them off what you can. And you're lucky if you get one. Okay, so we have one off. Now don't lay these things down loose anywhere it's close to each other, because up to 6 inches apart they'll decide to either push or pull one another, and they'll slam in. So now what I did is I took a piece of this tooling that I had, and the painted side I carefully put them on like so. Now they will pinch your fingers. Alright, so now you're approaching this aluminum, and you can put your retaining compound in. Put a little retaining compound here, simply slide it in the hole and push it down, and I suggest letting it set up. If it's a really loose fit, just walk away. 15 minutes later you come back. You'll have to take a hammer to bump this piece of metal loose off the magnet, because you will get a tad of retaining compound up there. Let that set, okay, and then the next one you come back to do, just hold your finger here as hard as you can and slide the second one in the empty hole and tap it in place. Just get it started. And then if you really want, you can, I'm going to try to put this magnet back on the stack without, I'm probably not going to worry. I'd like to get this in here. Well, that's so much for that. Okay. Alright, anyway, we're back to this. So these are in. You can use this. I use my milling machine vise. If one of them was tight for some reason, pushed it in, and so anyway, we're actually totally done with the build. I'm very happy. And by the way, these were, I think, 14 or 15 pound magnets a piece. So we got about 60 pounds pull on this thing, and here's the finished product. Alright, with that said, let me stop this for a second. Alright, here we are set up in the old Logan flat belt. This is in place, and as you can see, I mean, you can wiggle it using considerable force, but it always returns right to zero. And so of course this is a little more sturdy than the one that I had set up with the plastic and with a piece of 1/2 inch plywood back here. So anyway, you make the cut like so. Come in with your compound, and let's say I want to do 1/2 thousandths. Well, back here on the dial indicator, you probably can't see it, but it went in 1/2 thousandths. And now I can come back and I can take, of course, a total of 1 thousandths off, 1/2 thou each side. But it's very, very repeatable. And if you have to come way out for some reason, you can come back, and you can come right back to it and go to that. Let's see if I can get it back to that 1/2 thou. And I'm just taking a whisker off. So that's the end of the build, and I'm extremely happy with it. And when you get out on really big stuff, you have to go to a 2-inch dial indicator instead of this 1. But anyway, Hope you enjoyed it. Have a great day.